In this video, I'm going to be taking you through the basics of electronic configuration. Now, if you want to write the electronic configuration of nitrogen, nitrogen has an atomic number of 7 and a mass number of 14. Now, to write the electronic configuration of nitrogen, we have energy levels. We have the first energy level has S, the second energy level has SP, the third energy level has S, P, and D. The fourth energy level has S, P, D, and F. Now, S can carry 2 electrons, P can carry 6 electrons, D can carry 10, F can carry 14. Now, to write the electronic configuration of nitrogen, because it is at its ground state, and we're using the atomic number, we start with 1s, 2. We have 2s2, right? Capture with the s. Then we have 2, because P can carry 6 electrons, but because we only have 3 electrons remaining, therefore we put 2p3, right? Because this is 4 plus 3 making 7, which was 7 as the atomic number. Now, what if you want to write the electronic configuration of aluminium? Aluminium has 13 as the atomic number and 27 as the mass number, right? Now, we have 1s, 2s, P. We have 3 at the third energy level. We have S, P, D, right? I think this is enough for aluminium. So we have 1s2. We have 2s2. We have 2p6, that is 10, right? And we have 3s2, remain just 1 electron, so we have 3p1, right? That is for this one, right? Now, we have Fe2 plus. To write the electronic configuration of Fe2 plus, Fe is ion. Ion is a transition metal. Now, to write the electronic configuration of ion, first of all, before we look at ion 2 plus, we'll look at electronic configuration of ion at its ground state. Ion as its ground state, Fe, has electronic configuration, has an atomic number of 26 and a mass number of 55.85, right? Now, to write the electronic configuration, we have 1s at the first energy level, second energy level we have S, P, third energy level we have S, P, D, the fourth energy level we have S, P, D, and F, right? Now for ion, we have 1s, 2, we have 2s2, we have 2p6, that is what, 10. Then we have 3s2, right? We have 2p, we have 3p, sorry, let's count it, 3p6 now. That is what? So far there is 18. And we have 4s2. This is 20. Then we have 3d6. That's 26, right? Now, this is the electronic configuration of ion at its ground state. Now, to find the electronic configuration of ion to find the electronic configuration of an ion, right? Now, because iron is a transition metal, you subtract the two. By the way, whenever you see an element carrying a positive charge, what it means is that you're subtracting 2 electrons from the ion, from that element at its ground state. Whenever you see it carrying a negative charge, you are going to add 2 electrons. Now because Fe has plus 2, you are going to subtract 2 electrons from the electronic configuration of ion at its ground state. Now to take the 2 electrons, I know you might be tempted to remove 2 electrons from D, but that's not how it's supposed to be done. Because it's a transition metal, you subtract 2 electrons from the highest energy level. And as you've seen, we have 1, 2, 3, and 4, right? Now 4s is from the highest energy level, which is 4. So the 2 electrons will be subtracted from here. So the electronic configuration of Fe2 plus is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, and 3d6. This is the electronic configuration of Fe2 plus. Now what about the electronic configuration of chloride? Feel free to pause the video and try. Now chlorine is not a transition metal, so you can go ahead and do the subtraction before going to write the electronic configuration. In the case of iron, for example, that we've done earlier, if we had subtracted 2 electrons from 26 before going ahead to write the electronic configuration, what would have gotten would have been 3d4. But because we've written down the electronic configuration of iron at its ground state before taking 2 electrons from the highest energy level, that's why we could arrive at something like this, which is the right electronic configuration. Now for chlorine, let's say to write for chloride, we say, let's put down chlorine first. Chlorine has an atomic number of 17 and a mass number of 35.5, right? Now to write the electronic configuration, you can either follow the same pattern, or you just go ahead and subtract 1 from, add 1 to this atomic number. Now the atomic number of chloride is going to be 18, right? We added 1 to 17. Now to write the electronic configuration, we have 1, 2s, 2p, 2s, don't need to put 2 here, just put p. Then we have 3s, p, and d. That's for the 3rd energy level. 4th, I think for chlorine we can stop at the 3rd energy level, right? Now to write down the electronic configuration, we have 1s2, we have 2s2, we have 2p6, we have 3s. After this one will come, we have 3s2. This is 10, 12, then, and we have 3p6. Are we there? Now, so 3p6. Therefore, this makes it what? 18. And this is the electronic configuration of chloride. Now you can go ahead to write down the electronic configuration of chlorine, which you end up getting 3p5. When you add 1, it will be 3p6. That's because chlorine is not a transition metal, so it doesn't have effect. Thank you for watching.